As we started to explore polynomials, we're going to use a lot of the same tactics to add and subtract polynomials. When we simplified, we were adding and subtracting terms to make a simplified polynomial, but now we're going to be looking at more than one. So starting with example 1, where we add polynomials together. Our first example, 3n squared plus 3n plus 4. This is our first polynomial, and we won't worry too much about naming them right now, but just so you know, we can name them based on the number of terms. This has 3 terms, so it is called a trinomial, like a tricycle has 3 wheels. So that's our first polynomial, and we're adding to it n squared minus n plus 5. Now, and in the book, we'll see this as well. There are 2 different ways that we could add these together. One is using algebra tiles. And before we get started, we'll try it both ways. I do want to point out that n squared and minus n both have hidden coefficients. So n squared has a coefficient of 1, and this minus n has a coefficient of negative 1. Now you might say, well, I get the 1, here's the 1, but where's the negative come from? Well, remember, anytime we have subtraction, it's really adding the opposite. So there's my plus negative 1n. Now let's get some algebra tiles out. If you have these, or you can draw them in. I'm going to get those set up, and then we'll continue on. You can pause and get those set up now too. Alrighty, I've got my algebra tiles out here. Remember that the colors represent positive, the red represent negative. So I just have one red tile out here. The rest are the blue, green, and yellow positive tiles. The n squared or x squareds, the x or n in this case, and then the ones, each unit, so for our constants. When we're adding polynomials together, we are adding all of the like terms, which means in algebra tiles, things that are the same shape. So I'm looking for what things go together. As I'm writing my final answer here, I would take my n squareds. I have 3 of them from the first polynomial and 1 more from the second polynomial. When I write the simplified version after I add these together, that's going to be 4 total n squareds. Now I look at my n's. I have, sticking together here, 1, 2, 3 positive and 1 negative. Now, if you remember, 1 positive and 1 negative together makes 0. That's n plus negative n is 0. Whoop. And so we're left with these 2 positive n's plus 2n. And then I bring all of my units down here. 1 plus 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 1. 4 plus 5 is 9. Positive 9. And that's one way we can simplify our polynomial. Are not like terms because they don't have the same exponent. I'm looking for the same variable and the same exponent. 3n squared and 1n squared. I'm going to write here next to each other because they are like terms. Variable and exponent the same. But the coefficient is how I'm going to decide what they simplify to. Okay, so I included 3n squared and 1n squared. I also have 3n and negative 1n plus negative 1n. Those are like terms because their variable n is the same. And finally, like terms are constants. So I have 4 and 5. Constants are always going to be like terms. And now that I have these next to each other, I can show what I'm going to add together by grouping symbols, parentheses. 3n squared and 1n squared I add by looking at the coefficients. In total, 3 plus 1 is 4 n squareds. Just like I had 4 algebra tiles that were all big blue boxes. I also look at 3n and negative 1n. I'm still adding coefficients. 3 plus negative 1 is 3 plus negative 1 is positive 2n. Again, I simplify the coefficients. And finally, 4 plus 5 is 9. And notice I get the same answer when I use algebra tiles as when I just focus on the coefficients. This is going to help us. This method of looking for like terms is going to help us when we subtract. I would encourage you to try. Pause the video and try quick check 1, A, and B. Pause, and then I'll put the answers up here in just a minute. Okay, for part A, when you add those terms, part 1A, we have 5c squared, the 1c squared and the 4c squared, plus 2c, that's the 3c minus 1c, plus 2, the minus 5 or negative 5 plus 7. And for part B, x squared, that's the problem. Our answer is 3x squared plus 3x minus 7. Hang tight and we'll have our other 2 examples here in our